I regret not being clearer about how to solve quadratic equations by completing the square when you have more than one x squared. And in this case, I've got a dreadful scenario because I've got 10x squared, but it's minus 10x squared. Completing the square for that would be horrible. But the fact it's an equation means we can do a couple of easy steps. So the first thing I'm going to do here is line it up. So I'm minus 10x squared plus 20x plus 13. And if this was a completing the square question, if it wasn't an equation, then at this point I'd have to have a minus 10 outside the bracket, and then it would be horrible. But what I can do, because 0 is my friend, well, the first thing I can do is multiply everything by minus 1. Gets rid of the minus, and then I can divide everything by 10. And remember, the answers to this equation are the same as the answers to this equation and the same as the answers to this equation because we haven't broken any rules of algebra. So looking at that, I can now complete the square for that bit. I need to come down a bit, excuse me. There we go. So that, just shovel the 1.3 minus 1.3 out to one side. X squared minus 2x, I need x minus 1 squared in the bracket, but that would give me a plus 1, which I haven't got here, so I have to take away 1. And so that gives me that. And that means that I can go from here to here. So all I've done going from there to there is I've completed the square. And then the steps are the same as the steps from the video that I showed you. So add 2.3 square root. And, oh, made a mistake there. That should be plus 1, shouldn't it? So completing the square with more than 1x squared is fiddly, but if it is an equation, then you can avoid having to do that. You can fiddle about with it, so you end up with a single x squared, and that's pretty straightforward to do. Unfortunately, for today's video, we are back to using completing the square to help us sketch quadratics. So we can't use that trick that we can use when we're using it to solve equations. So here we've got a practical quadratic problem that sort of wraps up a number of the skills that we have looked at. First question you might be asking is, why are we not using our graphical calculator to solve problems like this? Well, you are very fortunate to have a graphical calculator, and you will always be able to use it to check your answers to questions like this. But because the specification at the moment doesn't say students need a graphical calculator, they can't assume everyone's got one, and so you have to use other methods. So you can use your calculator to solve quadratic equations because everyone's got a calculator that can solve quadratic equations. But we can only use the graphical things on our calculator to check answers. We've still got to do them manually. We're in a funny sort of hybrid situation. But we're definitely better off than those schools that don't give out graphical calculators. Okay, so here we've got a formula describing the motion of a spear that's thrown from the top of a tower. And what we have here is effectively a y equals something to do with x function, and our y is height, and our x is time. So we are showing how the height of this spear varies over time. Now, the spear is being thrown from a tower. So if I throw a spear from a tower, it's going to go like that, isn't it? And this is a parabola. And that's why its motion can be described with a quadratic, because we know that any quadratic, when you plot it on a graph, will always give you a parabola. So if I think about this as a set of axes, this isn't y, this is height, and this isn't x, this is 10. And this is time 0, and this is height 0. So if I use our sketching skills, remember there was a 4-step process, wasn't it? The first step was happy or sad. Well, unhappy because I've got a negative quadratic. Second step was, where does it intersect the y-axis? Well, in this case, that would be the h-axis. And that was what you got when x equals 0. Well, we haven't got x is 0, we've got t is 0 in this case. So when t is 0, I get 12.25 plus 14.7 times 0, which is 0, minus 4.9 times 0 squared. So I get 12.25. And you probably spotted that anyway. What does that actually mean in reality? Well, it means my tower is 12.25 metres tall. And the motion of my spear over time is going to look like that. After how many seconds does the spear hit the ground? Well, this is the x-axis intersection, isn't it? So this is step 3. This is what do you get when y is 0, although in this case it isn't y, is it? It's h. So at this point we have to say, right, when does this equal 0? And as always, the first thing I always do is I line it up. And then I've got all those methods up my sleeve to solve equations, including completing the square actually, but I'm going to use my calculator, and in fact I'm going to pause the video at this point and ask you just to solve that using a calculator, and then we'll come back in a second. So hopefully you remembered the process. You go to equation. This is a polynomial. Degree 2, that's the highest power of x, x squared, so degree 2. I've already entered my a, b and c values. So my two solutions, well, it gives me a rounded value here and an exact surd value here. So I've got 3 plus or minus the square root of 19 divided by 2. So my two solutions for t are 3 plus or minus root 19 over 2. However, this has to be positive, doesn't it? Can't go backwards in time. So that's the 3 plus root 19 divided by 2. And for that one, I'm going to look at the rounded value, and I'm going to use the default setting we use at A-level, which is 3 sig figs. So that is 3.68. So and of course I need to get my units correct. Height is in meters and time is in seconds, so that's 3.68 seconds. So we're building up a picture of the motion of this spear. So we then come to step 4, which is to find the turning points, to find the, in this case, the maximum height that it reaches. And they get you to do this in this question across 2 parts, because we find the turning point by completing the square. So the first thing I'm going to do is I'm going to take my quadratic and I'm going to complete the square. Now, no, it's not solving an equation, so I can't use that trick from when we were solving equations by completing the square. But the first thing I'm certainly going to do is to shove that out to one side. And then in order to complete the square, I need a single t squared. So I'm going to have a minus 4.9 outside my brackets. That's going to be t squared. Now if I take 14.7t and divide it by minus 4.9, that will tell me what I need to put with the t. So 14.7 divided by minus 4.9 gives me 3. Oh, that's not as bad as it was looking. And that 12.25 hasn't been affected by that at all. Right, okay, see if you can pick it up from there and complete the square. So you've got to complete the square for this bit, and then you've got to multiply out the bracket, and then you've got to add on the 12.25, and then see if you can use that to predict where the maximum value is. I'll pause the video again at that point. So this is a really fiddly process, isn't it? So I got to this point here, but actually completing the square for that bit isn't bad. So you get t minus 1.5, half the number of t's in the bracket, take away 1.5 squared, so that's standard. 12.25 still there. Then you multiply this out. The minus 4.9 doesn't affect that. You just put it outside that bracket. And then I've got minus 4.9 times minus 2.25, which is plus 11.025. And then that finally gives me, when I add those two together, that. And if you remember, trying to sketch this, if you start with not y equals x squared, but h equals t squared, that would shift it forwards 1.5. So that tells me that the maximum is when t is 1.5 seconds. The minus 4.9, well, the minus just makes it unhappy, flips it. And the 4.9 just makes it skinnier, so it doesn't actually change the location of the turning point. So I can basically ignore that. And then it gets lifted up 23.25. So that means the maximum value, the maximum height, sorry, 23.275. And that's it. So the maximum height the spear reaches is 23.275 meters, and that's after 1.5 seconds, and it hits the ground after 3.68 seconds. Let's check that on our calculators. Okay, so this time I go to graph mode. I'll delete that function. That was something I was doing before. So I'm going to type in my function. It doesn't have to be written it lined up. I can write it as it was in the question, but the only thing I have to do is, this is h equals something to do with t, isn't it? And I've got to change that to y equals something to do with x. So I'm going to type in minus 4.9 x, maybe we'll use that button, x squared, plus 14.7 x plus 12.25. I then draw it. Remember, I haven't thought about my axes yet. Okay, so that looks okay. I'm going to use the minus sign to zoom out, and then the, whatever you call this thing, the D-pad or whatever, to zoom around. So there we go. Now, of course, that isn't particularly attractive looking. Now I know the actual values here. I could manually type in the axes. So I could say, right, okay, I want my x-axis to go from 0 to, well, let's say 4. So from 0 to 4. Scale just means I want it numbered every one. I'm going to leave the dot. Sorry, need to go back to view window. Oh, I've got into a pickle there. Draw. Back to V window. Right, okay. Let's say I want my y minimum to be 0. No need to do negative. And my y maximum, well, let's make it 25. And then if I exit that, and I have to go to draw again. There we go. And we've worked out the location of the turning point and of the root, and I can confirm those using my favourite button on the calculator, Gsolve. So let's look at the root first. So the root was when x was 3.679, yep, rounded 3.68, that's all good. Exit, sorry, draw, Gsolve, and then the maximum value, there it is there, when x is 1.5 and when y 23.275. So I've confirmed that I've got it correct. So on page 36, question 11, we see a question which is pretty similar to the one we've just done. This isn't a spear being thrown from a tower, it's a diver launching herself off a springboard. But I'm hoping that with the one we've just been through, you'll be able to have a go at this one. Don't be afraid by the t greater than or equal to 0. That just means that, you know, time can't be negative, and that the time when she jumps off the springboard is t equals 0. And yeah, check it on your calculator once you've done it. Although, of course, it's from the book, so you can also check your answers So what about this deal I mentioned last week? Well, normally at this point, I would say, right, off you go, enjoy your summer, but you have an induction booklet that I would like you to complete, and then we'll do an assessment in September. And for some of you, that's absolutely what I'm going to ask you to do. And so I will send you an email next week on Monday the 22nd, just reminding you of that. And I'll put a copy of the induction booklet in. I know a number of you have been working through it alongside my videos. You know, doing a decent job of that induction assessment is really necessary to carry on with the course. You know, it's a good way of indicating if it's a course that you're going to be able to do. Some of you have kept up with the work I've been setting and have regularly sent me work and have demonstrated time and time again that you are more than capable of doing this course. So if you are in that position, you'll get a different email from me on Monday the 22nd saying, thank you for engaging. No need to worry about the induction assessment. You won't need to do it. Go away and have a really good summer. And I'm basically going to say, right, here's my spreadsheet with the most recent submissions. I've covered up the names to embarrass, not to embarrass you, to spare your blushes, but basically, if I've had the Unit 1 assessment from you, which I've had from all of you bar 3, and then the last 2 submissions, so there were some questions on completing the square the other day, and then yesterday I gave you some questions on the discriminant. Sorry, I'm doing this video on Tuesday. I know it's Friday when you're watching it, but that's why it's not coloured in. I'm sure over the next few days that will be filled in. But if you've done all 3 of those, you'll get the email on the 22nd saying, thanks very much, and have a great summer. And that is it. That's the last video. We've agreed that we will stop setting work at this point. We have turned a really unfortunate situation, and it's been so, you know, unfortunate, the whole closure situation, for a number of reasons. But we've turned it to our advantage because we are very nearly through the first 2 chapters of the course, and that puts us at a real head start. And so congratulations to those of you that have engaged. Congratulations to those of you who've got to know your calculator and are using it confidently. And I look forward to seeing you again in September. For some of you, it will be meeting you for the first time, which I really look forward to. And I trust you'll have a safe and enjoyable and really relaxing summer. Take care.